Now let us take one example to see whether the given set of vectors are linearly independent or not using the concept of matrices. We will be using the row operation to simplify that. Now let us take the vectors v1 that is equal to 1, 2, 3, v2 that is equal to 3 minus 2, 1, 3 minus 2, let us take minus 1, and v3 that is equal to 1 minus 6 minus 5. Now for this we will be having three constants, as we have been given three vectors, so we will be taking the three constants. Let k1, k2, k3 are three scalars. Now as we know, the definition of linearly independent says that we have to take the linear combination k1 v1 plus k2 v2 plus k3 v3. If we compare that with the null vector, 0 vector, if all the k1, k2, k3 becomes 0, that means the given set of vectors are linearly independent. And if we get at least one of the constant k1, k2, k3 as non-zero, then it will be a linearly dependent set of vectors. So we will be simplifying that. Now see, k1 we have been given v1 that is 1, 2 and 3 plus k2 into the second vector that is 3 minus 2 and minus 1 plus k3 into the third vector that is 1 minus 6 and minus 5. We will compare that with the null vector. Since these vectors have three tuple size, so we will be taking our 0 vector as 0, 0 and 0. Now we will be opening this bracket, simplifying this one. K1 we will take inside, so it will be k1, 2k1 and 3k1 plus 3k2 minus 2k2 and minus k2 plus it will be k3, we are taking k3 inside, minus 6k3 and minus 5k3. We will take that is equal to 0 vector. Now we will be simplifying this one. We will be adding the elements corresponding. First will be added with the first one. First k1 plus 3k2 plus k3, comma. Second with the second element, so it is 2k1 minus 2k2 and minus 6k3. The third part, that is 3k1, then we have a minus k2 minus 5k3, that is equal to 0 vector. Now we are having three system of equation. The first part is this one, second is this one, and third is this one. All the three are right side are 0, so by comparing we will be getting k1 plus 3k2 plus k3 is equal to 0. 2k1 minus 2k2 minus 6k3 is equal to 0, and the last is 3k1 minus k2 minus 5k3 is equal to 0. Now we will be solving this equation. We are having three equations: equation number 1, equation number 2, and this is equation number 3 in three variables. So we will convert that in the matrix format. It is going to be 1, 3, 1. Second row elements, k1 is 2 minus 6, and third equation says it is 3 minus 1 minus 5. Now Here it will be the corresponding K1, K2 and K3 is equal to 0, 0 and 0. Now here this is 1. With the help of this one we will making this 0 and this one 0. So we will be having that. So R2 minus 2 times of R1, and for making this 3 0 it will be having R3 minus 3 times of R1. We will be doing that operation here. R2 and R3 we are changing, so R1 and R1 will remain same. So it is 1, 3 and 1, K1, K2 and K3, that is equal to 0. Now we are doing the operation, we will be doing the rough work here. Now operation is R2 minus 2 times of R1. R2 elements are 2 minus 2 and minus 6, and right side is 0. 2 times of R1, we will multiply this row number 1, this is R1 by 2, so we will be having 2, 6, 2 and 0. We will subtract these two, sign will change, this will become 0, minus 2 minus 6 will become minus 8, this is going to be minus 8 and this is going to be 0. So we will be having 0, minus 8 and 0. And here we will be making this 3 as 0. The operation is given to us here, that is R3 minus 3 times of R1. What is R3? R3 is 3 minus 1 minus 5 and it is 0. 3 times of R1, we will be multiplying R1 by 3. We have here R1 1 3 1. So it will be, if we are multiplying this by 3, it will be 3, 3 3s are 9, 3 1s are 3 and 3 zeros are 0. We are going to subtract this, minus, 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 and here it will be minus, 3 minus 3 is 0, minus 1 will be minus 10, minus 3 minus 5 will become minus 8 and this will be 0. So we got the new row, that is a new third row as a 0, minus 10 and the next one is a minus 8 and here it is 0. Now our intention is to make this element as 0, because while finding the rank using the echelon form, below the diagonal we need to have 0. So this one need to be 0 using this one. This is 10, this is 8, both are of same sign. If we multiply the third row by 8 and second row by 10, both numbers will become 80. 10, 8 10 are 80 and 10 8 are 80. So we will be doing that operation. That is going to be R3. We will be multiplying that by 8 to make it 80. Both are of same sign, so we will subtract 10 into R2. R3 is going to change. So R1 and R2 will remain as it is. We will copy paste that. Now here it is going to be 1, 3, 1, K1, K2 and K3. It will be 0. Now R2 is 0, minus 8 and 0. Now we will be doing the operation here and we will write that. We are having, let us create some space for that rough work. Now we have the operation 8R3 minus 10R2. So R3 is, these elements are R3. We will multiply that by 8. It will be 8R3, that is equal to 0 minus 80 and 8 is the 64 minus 64 and 0 into 8 will become 0 and 10R2. We will multiply R2 by 10, so it will be 0 minus 8 into 10 will become minus 80 then again minus 80 here and 0. We are subtracting, so we will change the sign, and 0 minus 0 is 0, 80 minus 80 plus 80 is 0, minus 64 plus 80, it is going to be here 80 minus 64, it is going to be 10 minus 4 is 6, and here it is 7 minus 6 is 1, and this will be 0. So it is going to be 0, 0 and 16, and here 0. Now if we look at this one, below the diagonal we have made all the 3 zeros, so rank of this matrix is 3. Now if we look at the number of variables, that is the constants, we are having 3 variables given k2 and k3, and the rank of this matrix is 3. That shows that the given matrix have rank 3 since it is in echelon form and rank is 3. That is equal to number of variables. Now this matrix shows that therefore there will be 3 linearly independent vectors. So we had 3 vectors and we are getting the 3 linearly independent vectors. Therefore, given set of vectors are linearly independent. Here we are using the one property of matrices and rank, that is rank is equal to maximum number of rank of a matrix is equal to max number of linearly independent vectors in it. So we had 3 vectors and the rank is also 3. That means it is going to be linearly independent. Suppose the rank comes as 2 and we are having 3 vectors given to us. That means they are going to be linearly dependent. So always remember, rank of a matrix is equal to the maximum number of linearly independent vectors in it. So if we are having 3 vectors, rank comes as 3, that means all that given set of vectors are going to be linearly independent. And if we are getting the rank which is for example 2 or 1, in the case of this one where we have been given 3 vectors, then the given set of vectors will become linearly dependent. So always remember, the main point behind this is the rank should be equal to the number of vectors in that. If that is same, that means given set of vectors will become linearly independent, otherwise it is going to be linearly dependent. That's all for this lecture.